everyone, my name is Sunaina and today we will be learning about how to model addition, subtraction of fractions using different objects, pictures, words and numbers. The vocabulary we will be needing for this lesson are take away, subtract, less, difference, add, sum, more, total, fraction, equivalent, numerator, and denominator. As you can notice that I have written it out into different colors. Red represents subtraction, take away. Green represents addition. And blue represents all other words that we will be using throughout the video lesson. These colorful blocks. Look at this gorgeous square block. Assume this is equivalent to one whole. How would you name this block? And what about this? If you examine carefully, this square block is equivalent to 4 equal parts of this single block. This whole circle is equal to 2 parts of this half circles and 4 parts of this red circle. Knowing how many different pieces are there in a square or circle, determine each fractional part. Let's consider this yellow circle as a pie that has been divided into equal parts. So this one into 2 equal parts, and here is a red pie that is divided into 4 equal parts. What fractional part of a circle is this green piece of pie? Let's examine. There's 8 equal parts. Each part is equivalent to 1/8 of a whole circle. And same thing applies here. This is 4 parts, so each part is equivalent to 1/4, 1/4, 1/4, and 1/4 of a circle. And this is 1/2 of a circle. So going back to our question we just asked, knowing how many different pieces are there in a pie or a square block helps us determine each fractional part. The answer will be yes. So coming back to the square block, gorgeous square block, this was equivalent to 1 whole. This is half of this 1 whole, and this is 1/4. So representing it mathematically in symbols, we write it as, since this is 1 whole, this is 1, this is half of a whole square block, and we represent that in mathematics as 1/2, and this is 1/4, because 4 equal blocks, 4 equal single blocks makes 1 whole block. So this is equivalent to 1/4 of a whole. Now let's learn something about equivalent fractions. Show 2 or more parts of a pie that are equivalent to another part of a pie. Here's a problem on board. Here's a pie and it says it is shaded 2/8. So 1/8 and 2/8. And we have to find out which option is best that is equivalent to this pi, which is 2/8. So let's consider this first. So this is 1/8, 1/8, 1/8, 1/8. So this tells us that this is 1/8. And we have to find the fraction that is equivalent to 2/8. So this is not the correct answer choice. Number 2, the pi has been divided into 4 equal parts. So we just learned if it is divided into 4 equal parts, each part is 1/4, 1/4, 4th, and 1/4. So 2/4 is not shaded, 2/4 is shaded, which is equivalent to, if you bring it down to its lowest term, which is 1/2. Is 1/2 equivalent to 2/8? No. Because let's consider the last option, which should be our answer choice. 1/4, 1/4, 1/4, and 1/4. So we can clearly see that 1/4 of a portion is shaded, and we know that 2/8 is equivalent to 1/4. So answer choice 3 is the right answer. If you break 2/8 into 1/8 and 1/8, what operation we perform here? Yes, we added, right? Because 1/8 plus 1/8, 1/8 of a part and 1/8 of a part makes 2/8. Which is, if you visually bring this, imagine this was, let's examine just the blue one. So you can clearly see that this is, if you bring it up here, let's erase this portion and assume that we select this 1/8 of this pi, which is 1/8. So if you just look at the blue marks, this is equivalent to 1/4. Thus, we prove that 2/8 is equivalent to 1/4. What operation we perform to show that those parts are equal? We perform addition, as you can clearly see that. Can you model an addition situation using parts of a pi? So let's model addition situation. Let's use the same problem. So how do you model a situation? We say 1/8 plus 1/8 is equivalent to 2/8 or 1/4. And we prefer this answer because it is in the lowest terms. Okay, let's write this out as a statement. How would you write it out? I would say I have 1/8 of a pi, and my mom gave me 1/8 of a pi more. What is the total number of pi that I have? So when you examine a word problem like this, what do you do first? You go back and first circle the numbers, 1/8 and 1/8. So what happened here was more pi was given. So more. Let's write out words, more. And the question is, what is the total number? So total. If you remember the vocabulary we learned in the beginning, more and total represents addition. So this word problem can be modeled into addition, and which would look like that, and our answer to the problem would be I have 1/4 of a pie in total. Here is our star released question, 2013, 6th grade. Question number 15. Which model is shaded to best represent the expression below? And we have been given an expression here, which is 3/10 plus 2/5. And there is 4 different options, option A, B, C, and D. Now, before we go ahead and look at this option, let's go ahead and model how this expression looked like in a circle. So 3/10 means there's 10 parts in a circle. Let's go ahead and make 10 parts since the denominator is 10. And 3 parts are shaded. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have to shade 3 parts. Plus, our second fraction here is 2/5. So let's make a circle. And how many parts do we divide our circle into? As the denominator is 5 here, we divide it into 5 equal parts. So this is divided into 5. Assume this is equal parts. And it expresses 2 parts of the circle is shaded. So 1, 2, 3, 4, and 5. So 1 and 2. So just to make sure this is clear, here's a circle and here are our parts. So here's 1, 2, 3, 4, and 5 parts, and 2 parts are shaded. And here's a circle, and 1, 2, and 3 parts are shaded, and 7 parts are not shaded. So we actually came up with the solution. Now what we have to do is go back to the question and look at the option that looks like what we came up with. So let's see the first one. First, we count the number of parts the circle is divided into, equal numbers of parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we write it out as each part is 1/13 and 3 parts is shaded. So this represents 3/13. And this is divided into 1, 2, 3, 4, 5, 6, 7. So denominator is 7 and 2 parts are shaded. So 2/7. This is not our option. So option B is, let's count how many parts the circle is divided into. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our denominator for the first circle is 10. And how many parts are shaded here? 1, 2, and 3. So numerator is 3. So plus, and look at this circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Denominator is 10, and it is shaded. How many parts are shaded here? 1, 2, 3, and 4. So if you notice this fraction, if you recall, this fraction is not into its lowest term. If you remember, we said 1/4 of fraction is equal to 1/8 plus 1/8. So if you want to break this fraction down, 4/10 of a fraction is equal to 1/10, 1/10 plus 1/10 plus 1/10, and which means this fraction 2, 3, 4, 5, 6, 7, 8, 9, 10. Assume this is equivalent parts. 4 parts are shaded, 2, 3, and 4 parts. And if you actually divide this circle into 5 equal parts, so this is 1, 2, 3, 10, and let's use black to divide this circle into 5 equal parts. So 4 and 5. 1 part. So for 5 equal parts, only 1 and 2 parts are shaded. So if you divide into 5, 1, 2, 3, 4, and 5, that would be equivalent to 2/5. So now we know 4/10 is equal to 2/5. So we just cross this out. So this looks like our option, but let's examine the last one. The circle is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the denominator is 10, and 1, 2, 3, 4, 5, 6, 7 parts are shaded. And 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have 4 parts shaded, which is equal to 2/5, as we already know that. But this is not equivalent to 3/10, so answer B is the correct answer choice.